Now we move to part 2, the second session of the chapter, data structure and linguistics. In part 1, you study struct, union, and enumerated. And now you study linguistics. In future, you study stack, tree, and so on. So they can form by linguists. But firstly, you should understand what a linguist is. In front of you, this is a figure of a linguist. So there are some notes. Note 0, note 1, and note 2. At the end, we have new. That means there is a next field and is connected to new. So we have the definition for linguist. A linguist is another collection of nodes, so each of which contains data connected using pointers. And the first node in the list is called the head, and the last node is called the tail. And each node points to the next node in the list. You used to study arrays and you see the advantage of arrays. So we can easily and quickly access arbitrary elements. With linguistics, the size is dynamic, so it's easy to add additional nodes. It's easy to add or delete nodes from the middle of the list. Normally, when we have linguistics, so it can be accessed sequentially. For example, if you want to find the field element, for instance, we must start from the head and follow the links through our 4 other nodes. For example, you have a car lot. We have to design some function for working with the linked list of car lots. For example, we need to design function for searching. At that time, we need to search the database for a particular vehicle. We can add a new car to a database, and we can remove a car from the database. And for extension, database of car lot must remain sorted by vehicle ID from the small ID. But you don't know how many cars may be on the lot. So we must choose a linguistic representation which is going to organize our car lot. So firstly, we need to organize our car data structures. Over here now we have a struct car type with these elements inside. Over here now we have struct car type that are data type. We can use type definition for getting the new name for struct car type, and in future we can use car for declaring our variable. Firstly, you can understand that in future, if you want to design functions, we need to scan the list with the ID you want. This function returns a point right before the new node we want to work with, or it can return new point if such ID is smaller than the ID of the first node of the list. And for extension, you should understand the idea, because you design a scaling function like this and it returns a pointer. So we must pass 2 arguments, the first the head, and the second the third ID of the vehicle you want. It returns a pointer that is a reverse pointer, because you want to find out position that you want to insert the node into the list. So what we compare the vehicle ID you want to search for with the vehicle ID of the node right after the new node if we insert it into the list. But when we insert, you have the previous node, so that's not important. So we need to return is a pointer. So that's why these functions can return the pointer right before the new node position you want to insert into the linked list. And the second function, you want to search for a node with the vehicle ID. So we have the function search list. Of course, we need to pass ahead and search ID over here. We must return the pointer of the current node. If you want to add a node or you want to insert a node in the linked list, so we need to design the function for doing that. For example, over here, now you want to insert our new node into this position. So first you need to press the pointer over here. You know, the extension over here with the stroke kata, we have the next field. So it's storing the address or the pointer of the next node. And if you want to insert a new node, you have to press the pointer with the figure. And over here, you have a snippet of the program to add a node into our linked list. And over here, you have two parts. The first, we check if it's new, previous node. So you receive a pointer from scan list. And it is new, so we need to add a node, the new node, to the beginning position of the linked list, and else we need to insert it to the position between the previous node and the current node. So what if the list is not created yet? That means it has to be new. So at that time, you need to design the full function for doing that. I ask you to design the full function for this. That means that you can use the snippet for doing that. If you want to remove a node from the list, so we have the same idea over here. If you want to delete it, so you have to press the pointer and you connect from the next field of the node 0, you connect it to the node 2. If you want to remove the node 1, and then you use free function to delete node 1. And you have a subset from code to delete a node with this. So now we check an application for sorting a list. Now there are two ways to sort similar linked lists. The first one, if we use the idea to change the data in nodes, the links do not change. And the second way, the links change, the data does not change. We care about two things in each way. The first, the action of swapping. So depending on the first way or the second way, so we change, we swap the data or we swap the links. And the second action, we use the algorithm for sorting. At that time, we choose the algorithm and we give you to algorithm bubble sort and selection sort. So over here, you see the way one for sorting a list. Over here, you pass to pointer. And the second, we choose a bubble sort for sorting. So when you study class, so I will give you the full program for that, for depicting the problem. When we go to way 2, so firstly, you have a function for swapping two nodes. At that time, because if you want to swap, at that time you press the pointer, so we need to change the pointer, you need to change the value for the pointer head, so we need to pass the address of the head. Because when we go to swap, we change its value, so we need to pass its address. And this is the address of the pointer, so we have to type pointer when we pass it to this function. We have the same thing for upper side over here.